All right, great. So a brief introduction. So hi, everyone. We are happy to have Varsha Koushik here with us today for a computer science seminar. Varsha is a PhD candidate in computer science at the University of Colorado, Boulder. She is advised by Sean Kane, and her research interests lie at the intersection of human-computer interfaces and accessibility. Her research focuses on creating accessible smart technologies that empower people with disabilities in their everyday lives, and has been looking particularly augmented reality recently. Her work has been recognized by the University of Colorado Boulder through the Hope Shoots Hosja Award, the PhD Summer Research Fellowship, and the Carol Lynch Memorial Fellowship. She's also has been a Coleman Fellow at the Coleman Institute for Cognitive Disabilities, and received a Best Paper Honorable Mention Award at CHI 2019. And she's going to talk to us today about her work empowering people with disabilities through accessible user interfaces. Varsha.
Thank you, Rebecca, for that wonderful introduction. Hello, everybody. Good morning. I'm Varsha, PhD candidate in the Department of Computer Science at CU Boulder. And today I will be presenting my research titled Empowering People with Disabilities Through Accessible User Interfaces. So a little bit about me. Over the past 5 years, I've worked on empowering people through adaptive, accessible user interfaces in collaboration with people with visual impairments and people with cognitive disabilities. I've designed tangible computing tools for inclusive learning and supporting independent living. Besides research, I've also been an instructor and a teaching assistant for more than 3 years. So on this slide, you see a couple of pictures. One is me working on the Storyblocks system, which I'll talk in detail today. And the other one is a Swim Sense poster that I'm presenting, which is a swimming aid for blind swimmers. So people with disabilities are a large population group, which can include people with visual impairments. You see a person using a cane, people with mobility impairments, you see a person using a wheelchair, people who are deaf, you see a person signing on the slide, and people with cognitive disabilities. And most of these people use assistive technologies to support their everyday lives. So for example, people with visual impairments use something called a screen reader, which reads visual content in non-visual formats. So most phones today come equipped with screen readers. So whether you have an iOS phone or an Android, you can actually look up accessibility settings on your phone. So there's VoiceOver for iOS, TalkBack for Android. So they read visual content and present it to you in audio format. Some people with visual impairments also like to use Braille readers. So they like to attach it to their laptops and get that information in print. People who are hard of hearing might use hearing aids. People who are deaf use captions and other translation services. People with cognitive disabilities use a wide range of assistive technologies based on their range of abilities. So some people might use communication boards to talk about the activities that they want to do with their caregivers. Some people use head switches, so it's attached to their wheelchair. So it's a head switch which they use to operate iPads or any other technology. Some people use eye gaze technology to navigate user interfaces. So I don't know how many of you follow NFL or professional football. So Steve Gleason used to play professionally. He now has a condition called ALS, and so uses eye gaze to communicate with people, but also to use technology. But disability is not just a health problem. For a long time, it's been viewed through this medical model where disability had to be normalized. But now, more recently, it's been viewed through a social model where differences are embraced. So overcoming the difficulties of people with disabilities requires interventions to remove both environmental and social barriers. So more recently, accessibility is becoming mainstream. Accommodations are becoming universal design. So accommodations are resources or technology that are specially designed for people with disabilities. Universal design is that being available for everyone. So all of us, regardless of our abilities, are situationally impaired multiple times. So an example of accommodation that's very specialized for people with disabilities is an ESL interpreter. But universal design is captions. So all of us use captions. Go to the airport, there are screens, captions. There's too many people to have audio. Go to a noisy sports bar, captions. It's too noisy. We're not there yet. We're not at universal design yet. So all systems can be divided into 3 categories. Category A is the system expectations match the user's abilities. So a lot of systems today are designed that way, where the system assumes that the user has the abilities to use that particular system. Category B is the system's expectations don't match the user's abilities, and users need adaptations to use the system. A lot of people with disabilities fall under category B. So they need adaptations to use mainstream technology. Category C is mainstream technology adapting itself to the user's abilities. So imagine a system that can adapt itself based on what the user can and can't do. We're not quite at C yet in terms of mainstream technology. So most people with disabilities need assistive devices, but even with that, they're still not able to use a lot of mainstream technology. So some of them have started becoming creators of technology, and they've started adapting technology themselves, which requires a deep level of knowledge and also technical skills. So one example of that is Josh Mealy, who's a blind computer scientist and recently the winner of the MacArthur Genius Award. He's also the inventor of Blind Arduino to make electronics toolkits accessible. So Arduino, as you know, the hardware and the software is not accessible to people with visual impairments, but Blind Arduino lets Arduino becomes accessible to blind people. So what does this tell us? This tells us that people with disabilities can solve accessibility barriers with technical skills and self-determination, which means they need computer science skills. So there's been a lot of effort to making computer science accessible. So in 2016, President Obama signed the CS for All initiative to empower all learners to learn computer science. And this has boosted a lot of efforts. A lot of introductory programming tools have been invented. So what are introductory programming tools? So back in the 70s, when personal computers were created, a lot of people started learning programming. But back then, programming was taught through math-based activities, and it had a lot of complicated syntax. You see Lisp code on the slide. So children started disliking programming, and they moved away from it, and they just stuck to computer literacy, where they just learned applications of the computer. So a few years later, Seymour Papert and a few other researchers came up with this new approach where programming is taught in a way that's easy to understand, that's more engaging, and kids can express ideas through projects. So from this, a number of tools were created. So one thing they focus on is it's really important to learn computing before you learn programming. So if you want to solve problems using computers, you need to provide exact instructions and under every possible scenario. And we humans don't tend to do that generally, which is one of the biggest challenges to teach children programming. So I'm going to go over a few examples of introductory programming tools. So one is Alice, a story-based programming tool to create 2D and 3D movies. This motivated a lot of girls to learn programming. Then you see a number of tangible toolkits like Osmo or Microbit, where you use physical objects to control something on screen. Then you have block-based languages like Scratch or Blockly or Hour of Code, if you're familiar with. So these use colored blocks where you drag and drop them to create interesting things like animations, movies, or videos. The question is now computer science truly for all? Not really. Many underrepresented groups are sort of left out from the efforts that have resulted from the current definition of CS for all. One such population is people with disabilities. So a lot of these tools that we just saw, they use visual representation of programs and interactions. They use a lot of mouse-based interactions, which are not accessible to people with visual impairments. They also use color to identify different elements, which are, again, not accessible to people with low vision, people who are colorblind. It's great that some of these tools are multimodal, like Osmo, but again, if you have tangible blocks without any features that are easily identifiable by touch, it's not accessible to people with visual impairments. They're also not compatible with assistive devices. So all of the tools that we just saw, like even Scratch, it's not very compatible with screen readers or any other assistive device that you may use. So people with disabilities may not be able to even access that tool. A lot of these tools also use very similar block shapes. So people with low vision can have a very hard time trying to figure out which blocks to assemble one on top of the other. And you also see that these tools are quite busy. We have the toolkit, the workspace, the output, all in one window, which makes it really cognitively overwhelming for people with cognitive disabilities. And lastly, these tools also have pretty inaccessible feedback. So a lot of the feedback is also very visual through animations or videos. The tangible tools that we saw also have visual output, and some of them have these animated tutorials that keep going on the side, which can be quite distracting. So what can we do about it? So there's been some research in making introductory programming accessible to people with visual impairments. So just going over 3 projects. So one is pseudo blocks, which uses keyboard movements to create block-based programs. Blocks for All, it uses screen readers on a touch screen where you make block-based programming accessible on a touch-based device like your iPad. Code Jumper, it uses tangible pods which you connect together. It's completely tangible to make music and you learn programming concepts. It's meant for both sighted and non-sighted students to work together. There's been some efforts around computing education for people with cognitive disabilities. So a lot of it is focused around universal design for learning framework, which focuses on multimodal instructional strategies, providing scaffolding that is breaking down things into simpler steps, and supporting exploration through open-ended activities. Particularly for people with cognitive disabilities, computing education is essential because a lot of their employers demand digital fluency. So it really becomes important for them to gain technology-related skills. So inspired by all these efforts, I was motivated to create computer science education tools where inputs and outputs are accessible. So I wanted to create multimodal tools that use low-cost materials because I envision these tools to be used in classrooms, and K through 12 budgets, so you have to use affordable everyday materials. Besides tools being accessible, I also wanted to create something that made programming fun and engaging to learn. So I'm going to go over a few current projects from my research. So one is Storyblocks. It's a programming game to create audio stories using tangible blocks in a physical workspace. So it addresses some of the problems that we talked about. It has accessible input through easily identifiable blocks, which I will talk in more detail. It also has accessible output through audio stories. So this breaking down the features of the system. So it has a physical workspace, so a 2x2 inch layout, which is actually built using PVC pipes, tangible blocks, so that are made from acrylic, software. So we use a computer vision library to track all the blocks in real time. And then audio feedback where the camera is attached to the system and it will parse all the blocks and give you that story with different voices and sound effects. So the tangible blocks, there are 3 kinds of blocks that Storyblocks supports: characters, actions, and control structures. Control structures are the programming concept. So right now it's sequential instructions and then loops and branches. So if you observe carefully, the characters have square-shaped bases, actions have angular socket bases, and they all have some kind of tactile marker on top of them. So it's quite easily identifiable by touch to differentiate cat from mouse or spoon from cheese. All of the blocks also have reactive vision tags to track them in real time. So audio stories. So the output, you can hear it with different voices for characters and sound effects for actions in a sentence. This is to make outputs more fun and engaging. We also address accessibility barriers around visual inputs. So figuring out how can you provide outputs in non-visual format. So for example, let's say we have an example story. Cat says hi, cat chases mouse, cat explodes. How will you hear that? Not sure if you can hear it.
Cat says hi.
It is playing, but it says cat says hi and you hear like a purr sound, and cat chases mouse and you hear a running clicking sound, and then it says cat explodes and you hear an explosion sound. So together, how can someone use Storyblocks? So first you identify the blocks using their tactile markers and you start assembling them together. So all the blocks go one line at a time, where all the characters go first, the verbs come next, and then you start assembling them one line at a time. Once you finish, you press a key on your laptop and the camera tracks all the blocks, converts them to audio story. This is the same story that we just heard, but it's in a physical format. And when you press a key, you'll hear it with different voices and sound effects. So to evaluate Storyblocks, I used a method called usability studies. I tested it with students, teachers, and Braille specialists, which is where I saw value in for story blocks. They worked in groups because in classrooms, they normally work together with students. We asked them to recreate stories, but we also asked them to create new stories because we wanted to see what kinds of extensions they would add to the system. We found that users added multiple extensions to story blocks. So they created new blocks, as you can see. They created new characters like teachers, coffee, donuts. They even added Boolean operators like and. They added the number of times for loops. They also added strings, new data type to their stories. All the participants used a number of collaborative programming strategies. So some of them acted as programmers while the others acted as debuggers or compilers, where they would constantly check if their fellow participants are making programs in accordance with the Storyblocks syntax. So some takeaways from this project are multimodal tools can be very useful to write algorithms. They can be accessible to both sighted and non-sighted students. And a lot of teachers express that it has implications for other domains like learning algebraic equations or maybe Braille letters. In all, participants found storytelling to be a very compelling method to learn programming. And one of the teachers who has prior experience in computer science talked about how it made sense to her more than her computer science class that she took 20 years ago. So based on the findings from Storyblocks, I wanted to expand introductory programming tools to people with cognitive disabilities because there is an unmet need there in computer science and programming. So I started integrating myself into communities. I started attending conferences and events where organizations that serve people with cognitive disabilities would be. And I found one group which particularly intrigued me. So this is a classroom where students are working on projects in front of their computer, learning computer science, and an instructor is helping a student. This looks a little different from traditional classrooms, right? This is a classroom where adults with cognitive disabilities are learning computer science, and I call it Code Club. So Code Club received an award from the Coleman Institute of Cognitive Disabilities from CU Boulder, and it's a leader in cognitive accessibility. So Code Club focuses on empowering individuals through technology to increase independence, engagement, and communication, and they serve individuals with a wide range of disabilities. So I wanted to understand their motivations and goals for learning programming, and I wanted to understand their pedagogy. I really wanted to understand how they structure their computer science curriculum. So I used this method called ethnography, which is synonymous also with field studies, where you go and learn more about users. I spent about 2 weeks in Code Club, where I observed classroom sessions, I interviewed students and teachers, and I also watched project demonstrations. So what did I learn? So one of the biggest findings was that members were really motivated to customize their own assistive technologies. They wanted to modify smart devices. So I found out that most Code Club members use smart devices like voice assistants, smart lights, buttons, but they were not very accessible to their needs, so they wanted to customize it. So at first they started rewiring these devices, adding more sensors. So you see an example on the slide of a pillow sensor where they added a tool called Makey Makey and added some sensors. So when a person presses once, it says yes. When they press twice, it says no. So that's a way a person can communicate with their caregiver. But they soon realized that just the hardware itself won't do. The behavior of these devices had to change. So which means they needed programming. So they started learning programming, and they started learning it through Scratch. But they encountered a number of accessibility challenges while learning with programming through Scratch. So one, you can see that Scratch has different colored blocks that are stacked together. So they had a hard time reading and comprehending what that code meant. So then they started color printing all the instructions on paper, but the printed version had different color and the screen had different colors. So they had a really hard time matching those blocks and writing programs. Like I mentioned, Scratch also has this animated tutorial going on, which tripped them up because a lot of people try to edit the tutorial itself rather than going to the workspace and actually dragging and dropping the block. So they would keep getting confused that the tutorial is just for them to follow and not actually do it when the tutorial is showing you all the steps. Some people also had problems with their assistive technology. There was one person who used a head mouse pointer and it just didn't work with Scratch. So that particular member worked with another person and pair programmed in class. So to overcome the accessibility challenges that they faced, they had this peer mentoring model going on in Code Club, which I thought was absolutely fascinating, where students with cognitive disabilities who were more experienced were mentoring other students with disabilities. They would help them brainstorm projects, they would debug errors, they would even substitute lectures when the instructor wasn't around. And students were very excited to learn from their peer mentors rather than from their instructor. So one of the mentors talks about how great of an experience it is for him to work with people who have similar disabilities and teach them something new. Besides learning programming, the instructor felt that these classes gave them benefits beyond computer science, like soft skills or social skills that are very valuable when they get jobs, like independence, punctuality, and leadership. And this was also one of the motivations for individuals to get technology-related jobs in the community. So far, like one Code Club member has graduated from this program and is working in the IT department at a community library, which is really great. So some takeaways are this need for a customizable smart device, so a device that is customizable to their abilities, that provides support in place, that provides a wide range of support. And also this idea that people with cognitive disabilities are motivated to do activities when it's relatable and when they can form a connection. This goes back to the peer mentoring model that we just talked about. So I started digging deep into literature and starting reading papers around motivation and customizability, particularly for this population. I learned that most people with cognitive disabilities live in community homes, but they envision to live independently and be self-sufficient. But this is tied to their ability to perform daily routines and the amount of support they need during those routines. I keep saying routines, what did they mean? They're categorized into two types: activities of daily living, which are quite personal, things like brushing your teeth, eating, cleaning, and instrumental activities of daily living, which are quite social, like traveling, communication, and shopping. To overcome the challenges that individuals face because of their disabilities, they use assistive devices for prompting. So prompting is breaking down a task into simple steps, and it can include text, images, or verbal instructions. All of us use some kind of prompting, our phone notifications, or for calendar, or alerts that you get on your phone. But these prompts are focused on needs around planning, remembering, making decisions. And these can be in lots of formats. So some people need stepwise guidance, so maybe it's a list of steps. Some people only need a reminder to do a task. Their individuals have a wide range of abilities, so the support is also in a wide range. But these traditional systems have some limitations. One, they're very passive. They tell you what the steps are and just assume that the individual will do it correctly without any feedback. They're also not very customizable. So like I mentioned, individuals need a wide range of support. So it's not very robust for person-centered customizations. Third, there's a lack of end user involvement. Individuals are not really involved in creating or managing their own prompts. So to overcome the limitations of traditional prompting systems, organizations started adopting a lot of smart home devices, just like Code Club. So this, they thought, would give individuals more independence. So these individuals pair these with assistive devices. So it's very common for someone that uses a head switch to pair their Alexa with a blender. So then they use their head switch to trigger Alexa to turn on the blender, and it runs. But again, these devices have limitations. One, they're passive. They do give you some form of feedback, but it's in a certain format and it's within a time interval that you have to receive that feedback. It's not constant in the location of their activity. They also don't support end user customizability. So these devices are really complex. So there's very little resources for people with cognitive disabilities to customize smart devices. So based on whatever I learned from Code Club and literature, I wanted to create a customizable smart display for people with cognitive disabilities that can give them prompts and feedback based on their needs. So research tells us that augmented reality can really support providing constant prompts and feedback in situ. That means in the location of the activity. So I started looking at hands-free augmented overlays that can project multimodal informations in place. It's really nice because it can also integrate other elements like gamification to make tasks more engaging. So I wanted to now create an augmented reality smart display that is customizable for people with cognitive disabilities. But there's a couple of questions that need to be answered. So if there's this display, what kind of information do people actually want to see? And the second one is, what tasks can this display support? So I'll talk about the first question. So I used a method called participatory design, which is where you integrate your users throughout the design process rather than making a system and then taking it to them. So to understand what kinds of information people want to see in this display, I actually went to them and I interviewed them and then asked them about what devices they're using right now, what limitations or challenges do they face. Then I presented them with a canvas using this design tool called Mural, and I gave them the ability to sketch, add media like GIFs or pictures. And I told them, like, okay, imagine this is an augmented reality display that is helping you with your everyday activities. Let's talk about what this device can do. And then we discussed some potential uses of this device in community homes. So I'm going to briefly go over some findings. Avatars were the most popular strategy that participants came up with. They wanted avatars to help them motivate do daily activities like brushing their teeth or cleaning or washing their hands. So you see different kinds of strategies that they use. So one avatar is helping them check their progress while they're brushing their teeth by taking a picture. And another avatar is singing to help them track how people wash their hands. There's an avatar, so one person really liked Drake, so they wanted Drake to constantly motivate them to not give up and stay on task. But at the same time, you see that this device also provides options if they want to call their caregiver right away and get physical assistance. Then another avatar participant designed an avatar which uses Snapchat filters, where once they're done with the task, the avatar will project a tiara on them and do like a beauty pageant wave with them. So participants were really creative in the support that they wanted to receive. Another strategy that participants use is gamifications to help people stay on task. So here's a story-based game that one of the participants made for emphasizing flossing, where you have to keep flossing. There's this anime character that's walking on a tightrope over a gorge filled with alligators, and you have to keep flossing to save your character from falling and dying, then to cross over the cliff. Another design was this immersive visual experiences to, again, capture attention, help people stay on task. So one design on the left is, at first, when somebody walks into the bathroom, they see a really sad forest, and as they wash their hands, this forest gets filled with flora and fauna. And on the right, you see this design where, again, you go and stand in front of a serene mountain scene with soothing music. And then you also see a timer for 2 minutes to brush your teeth, but also it's overlaid with a functional, funny instructional video to help you brush your teeth. So some takeaways from this was that individuals find visual AR feedback, especially avatars, really helpful. So it could promote this idea of a virtual buddy. This goes back to the peer mentoring model where it's about feeling a connection when you're doing activities. I also found that it's really important to include personalized need-based customization. So not just customizing the display, but customizing the task itself. So people need different levels of support. So some people need to know that you need to put 2 pumps of soap, or make sure you check the water temperature before you put your hand underwater. So I mentioned that these individuals need constant feedback. So thinking about when and what kind of feedback is given to them while they do their activity is also important. So now that I know what kinds of information this AR display can provide, I need to start thinking about what activities can this display support. We need to think about what activities individuals are struggling with currently and that they want to improve, and then think about how this display can support them. So I used the FOG model, which is a popular model for developing behaviors and habits. So what this model says is that with enough motivation or ability, something becomes a routine. So for example, let's take 20 push-ups. It's hard to do, and quite honestly, not most people are motivated to do it. Versus 2 wall push-ups, it may not be that hard. Even though you have low motivation, it becomes a habit and you do it. So I applied that FOG model to daily activities. So I wanted to understand how frequently are people doing everyday tasks. So here I'm zeroing in on essential daily activities like brushing or cleaning that are tied to their idea of independent living. I wanted to understand how motivated are they to do these tasks, and then what are some challenges for them in doing these activities. So I used a method called design interviews. You can think of this study more like card sorting. So where I presented them with three canvases. So the first one is around frequency, where I told them, come up with a list of activities that you do in a week, right from waking up to going back to sleep. And then I asked them to sort it based on how frequently they do it. In the second canvas, I told them, take the same set of activities, but now sort it in terms of how much you like doing it. In the third canvas around difficulty, I told them, again, sort the same set of activities, but now based on how easy or difficult it is for you to do it. Here's a snapshot of some patterns that I saw. But again, this is a very tiny snapshot of all the data that we've collected from the study. So I apologize that I cannot show all of the data. So some tests that they did all the time are essential activities like brushing their teeth, but with low motivation, they didn't care about it or didn't like it. And for some people, it was also very difficult to keep track of how long they should brush or which side they should brush for how long. They loved things like high motivation and easy tasks were things like watching TV, their hobbies, hanging out with friends. Some infrequent tasks were cleaning or making the bed. They just didn't like doing it, even though they have to do it. It was also quite hard for them, mostly because it was physically challenging, and also mentally it took too long and there were too many parts to it. So I will talk a little bit about accessibility barriers where this device could potentially support. So they had difficulty tracking progress. How long should I brush my teeth? The answer is 2 minutes, but how do you keep track of those 2 minutes? They're also unable to make decisions, especially around packing their backpack. They don't have a checklist. So like, should I pack my baseball bat for practice? Should I pack this other thing? Or is my fajita cooked enough? Did the timer go off? The challenges with constant monitoring. So a lot of times they would have something on the stove, even though they had to come back, they would just leave it and go away, just really dangerous. They also had difficulty maintaining attention, especially in terms of cleaning or tasks that took really long time. And sometimes they just lack motivation for like making the bed. They have to do it, but they didn't want to. So they never did, even though it's an essential activity. So some themes where how I could support these particular activities using the AR display is integrating personalized motivation to help them practice regularly. So sort of linking less liked activity with favorite ones. So you can think of like you get to watch interesting videos before you brush your teeth. Multimodal feedback can also help them stay on task. So when they are cooking or when they're cleaning, they get to watch something that they like, or they get to play a game. Rewards can also help individuals feel more confident. So rewards can mean a lot of things. So maybe for someone, if they finish brushing their teeth at the end, they get to watch their favorite cupcake video, or they get to play a little mini game, or they get to they get to watch Instagram or a reel or something like that. So now I know what kinds of prompts and feedback individuals find helpful. I also know what kinds of activities and barriers this device can support. So with that knowledge, I'm building Activity Mirror, an augmented reality smart display to customize prompts and feedback. So Activity Mirror can do 3 things at the moment. You can practice and customize everyday tasks with avatars and augmented reality. So this is a prototype setup that you've seen in a bathroom. You can also customize the task algorithms, and you can solve challenges to reinforce activities. So in practice, you have animated characters demonstrating activities in augmented reality and interacting with individuals. So this can help engage and motivate individuals through each step of the activity. It also provides multimodal support that can be customized in real time. So what does that mean? So there's device level customization where the display itself is customizable. So you can tweak the avatar that you see. You can modify the prompts that you see or hear. You can add interesting media like personalized songs or videos for your activities. Some individuals get really overwhelmed with videos, so you can toggle between images and videos. You can track your progress by seeing how many steps you've done. You can also interact using voice or touchscreen with this device. So that's the device level customization. You can also customize the task itself. Why is this important? So individual abilities influence how a task is performed, and this changes over time. Maybe some people needed 2 prompts now, 6 months later, maybe they need 1 prompt, or maybe they need 3 prompts. So the task changes. So some tasks by themselves evolved. So think of some activity that you did maybe 10 years ago, and now there's a new appliance. So the way you do that activity has completely changed. There's change in support. So it's very common for individuals to not have enough support. So maybe they did this activity with 2 caregivers. Now they only have 1 to do this activity. Or a lot of individuals work together over the weekend. Sometimes they cook together. So then the whole dynamic changes. What kind of support do they need there? So here you can change the algorithm of the task, as in change what the steps this avatar will show. You can add new blocks, you can delete blocks, you can change the order of blocks. We're still using block-based languages here because the drag and drop action is actually useful for people with cognitive disabilities, but they're much larger. They're easy to, they're not smushed together. So then using Activity Mirror, you can also play mini games or solve challenges. So caregivers often have individuals practice closely related skills closely related to the activity in other forms. So it's quite common for individuals to play math-based puzzles every day for 10 minutes to reinforce money management, or they sometimes play decision-making games to help them reinforce road safety or social interactions like shopping. For example, now, especially with COVID, after people have been home for more than a year, they've had to relearn how to go into stores and shop and interact with cashiers. That's the thing caregivers are working on with individuals right now because they were away for such long time. So we're sort of using the same concept here, where you can play these mini games that are less than 30 seconds. So in this is an example where the avatar will put so much paste that the toothbrush itself breaks. Putting too much paste and soap is actually a common problem within this community. So this is an opportunity for individuals to see and reflect that, hey, this avatar is doing something wrong, and here's how it needs to improve. So my plan is to evaluate Activity Mirror using usability studies, where I primarily have 2 phases. So yes, they get to customize the task and the what of the device when they practice an activity, but it's also important to present a personalized interface to individuals. So at first, I will present paper versions of Activity Mirror and have individuals customize the default interface that they see, and then use Activity Mirror where they actually have to practice it in their everyday activities like brushing teeth or washing hands. Some evaluation metrics that I'm using is how confident do individuals feel when about doing activities once they've interacted with Activity Mirror. And self-reflection. Can they identify and reflect on errors in activity, especially this is tied to the mini games or the challenges that we just talked about. Some projects in the interest of time that I'm not going to talk about today, I didn't talk about earlier. Swim Sense, which is a swimming aid for blind swimmers to help them track where the wall is. So right now they use a tapper who taps their shoulder every time they reach the end of the pool, which is very expensive. Unsnappable sensor, a fabric-based sensors where you have these snaps at the end of fabric where you have sensors that are sewn in, and you can activate them by snapping these fabrics together. So now I'm going to talk about my future research and my research agenda. So at first I want to create learning environments for individuals with disabilities to develop privacy awareness, specifically people with cognitive disabilities. So even though these individuals use a lot of smart devices, they have very limited awareness on how these devices work and also privacy implications. So compared to other populations, this particular population is more likely to be monitored more. They use a lot of sleep tracking, food tracking for individuals, and they're also more likely to have their data managed by someone else, like their caregiver or case managers. So it's really important to help them become advocates, self-advocates around privacy and security. So I'm interested in exploring educational technologies that teach them about these devices and also taking that forward around privacy. So this can take the form of games, it can be robots, it can include electronic prototyping where they build sensors. So there's a lot of opportunity for small scale projects in this area. The second one is looking at per user customization in shared environments or shareable displays. So I mentioned this earlier that individuals live with other people with cognitive disabilities, and they're all dividing chores, like they're all cooking together, they're all cleaning together, but they all need individualized support. So, and if you have individual iPads, there's more likely to get misplaced or they don't bring it to the activity. So if we think of an ambient display that gives you AR feedback, but gives feedback for each individual as they're doing the activity, as a group, what would that even look like? There's also some privacy implications here, because a lot of individuals, let's say they're in a shared environment like kitchen, but they're cooking by themselves and they have this device in front of them. They most likely don't want their other roommates to hear what this device is telling them or what they're telling this device. Sometimes they even don't want their caregivers to know what how they're interacting with this device. So how can this shared device that's in this shared environment, how can it help with that? So there's some ideas that I can draw from prior research. So prior research has used like projections around AR. They've also used headsets with projectors that display AR content while you're doing everyday activities. So there's some ideas that I can draw from there. Again, there's lots of opportunities for small scale projects in this area. So with that, I want to take a minute to thank my advisor, Sean Gain, and my committee members, Clayton, Tammy, Mike, and Amanda. I also want to thank my lab mates for their constant support. And I want to thank the National Science Foundation, the Coleman Institute, and CU Boulder for their generous support for my work. And I want to thank you all for your time this afternoon. I'm happy to take questions now.
Questions for Varsha? If you're on the Zoom, you can raise your hand and we can try to figure out what the best way to get your questions.
Oh.
I didn't see who was first.
Can you say something? Quite interesting. Can you say something about flow control? Once what I saw.
Oh, yeah. So are you like talking about like functions or more?
Anything else?
Oh, we did have a branch, which is more of a choice, which were like physical branches coming out of the block. But so that was where you have a choice in the story, and then you have two branches coming out, and there's like, if this choice, something else happens in the story. If this, then this happens. So that's kind of the if else that's going on in story blocks. For more complicated stories, it'd be interesting to think about maybe like if you think of if else structure in programming, so it's more nested. So trying to think of what a nested representation would look like in story, rather than having it in the same format, maybe trying to figure out ways in which it's more, I see it more like a sort of like decision tree that's coming out, and maybe in that format. But the design challenge there would be in terms of the amount of space that it takes, because it's a physical environment. And if it's a 2 by 2 feet, what kind of stories are possible? Or even a classroom table, you only have that much amount of space. So how big should these blocks be? If you're still going with the string structure, can you just have different maybe lengths of string that you can just attach quickly and make if else blocks? That would be a design challenge to think about.
And also places in which the conditional depends upon something that was said earlier.
Yes.
So a place to keep variables.
Yeah. So I think we've grappled this challenge around variables when we made story blocks, thinking about if there are variables, what would they look like? So we sort of went with what if the characters or actions themselves, the objects itself count as variables in the story, because this idea of programming and variables are such an important and integral part, which was one of the design trade-offs that we had in the story block system.
Sarah, and then we'll get to Izzy on the Zoom after Sarah.
I have a couple questions. So the first one is, why did you choose to create a mirror for your augmented reality? It seems as though people are doing tasks in multiple areas throughout their home or maybe out in the public. Why didn't you choose to use a mobile device?
The reason we didn't choose a mobile device is because so right now they use iPads at the moment. but they constantly leave the iPad in their room and they go to the bathroom. So they forget to actually bring their devices. And when they're doing the activity, let's say you're in the bathroom and you're in front of a mirror, you have to constantly pause and then look at this other device. So there's a lot of context switching.
Right, but what about something like Google Plus?
Sure, yeah, you can wear Google Glass, but again, it's still, it is possible to wear Google Glass, but it would, I guess individuals have to be responsible, or caregivers have to figure out that individuals bring them every morning to the bathroom, wear it in front of their mirror, or if there's a technical glitch, then figuring out and how to work with that. It's just this, and a lot of individuals also don't like to wear something. Imagine someone getting up in the morning, going to the bathroom. They might not want to wear a glass first thing in the morning when they brush their teeth. So thinking about like, so the reason we're going for this mirror is it's hands-free. You don't have to do anything. There's no setup involved. You just go stand in front of it. And it's just there. You're just watching it. And we did think of like what kind of, it somewhat limits the kind of activities it can support. So right now we're focusing on a lot of tasks in the bathroom, but there is potential for that task. Let's say, the checklist that I talked about, maybe you're walking out through the door, next to your door, there's a mirror. It just quickly runs a checklist like, hey, do you have your keys? Do you have your wallet? Do you have your bag? All right, you're ready to go. Or in the kitchen, it could be useful. Or in their room, like, brushing your hair or dressing up. But that dressing up has some privacy implications, but it's still valuable to have a hands-free device for this population.
Okay. And then the other question I have, this is a little bit more of a random technical question. So when you're doing your qualitative data analysis, what method are you using?
So I've used thematic analysis. I've also used open coding techniques. Those are primarily what I use.
Izzy, you want to unmute and ask your question, or you want to chat and I'll ask you?
Yeah. Okay. Can you hear me?
Oh, wait. Okay. 1 second, Izzy. Varsha, do you want to switch the audio? So mute yourself.
Sorry, I don't know if I should speak or I'm confused. Okay, sorry, got it. Okay, I just wasn't sure if I could talk or not. Anyways, I just want to say thank you. I really enjoyed your talk. I wrote down a lot of information. I learned a lot from it. A question that I had for you is just like, as a student, like if we're really interested in your research, like what do you suggest we do?
Can I just talk?
I think she can hear. Can you hear us now?
Oh, okay.
Yeah.
First thing is, please come talk to me if you're interested. If you're taking my class, come talk to me. Even otherwise, just like, send me an email, just like knock on my door, just like come talk to me. That would be the first step. And then taking that forward is like really brainstorming research ideas. So I usually with students, my plan is to talk about some ongoing projects, but at the same time, give them the opportunity if they are passionate about a topic, asking them if they feel really strongly, no, I'm passionate about this particular area. I want to work on it and I want to see where that takes. So then we start figuring out what are some possible products there. And then we would work on it. But if they're interested in one of the ongoing projects, then again, we figure out where places they can contribute and work on, and then take it from there. So that would be a place to start. Not sure if I answered your question. Oh, okay.
Yes, you did. Thank you. Well, I'll definitely come talk to you later today at the student meeting.
Oh, okay. Yes.
Great. And Saima and then Julia on the Zoom.
Okay, thank you so much, Varsha. I really enjoyed this talk. I think what I find really interesting is that you've done a lot about research thinking about the psychology of human behavior. and then thinking about ways that technology can assist and creating assistive devices. And you mentioned this earlier, and I wonder if you could speak a little bit more about the balance between data collection and this constant monitoring of human behavior and privacy issues, and creating assistive devices that may collect data that may be used for things that may not be intended for creating kind of technology that you're thinking about.
Is this a question in my work or in general how this works?
Yeah, you could talk about your work.
So I think right now so I'm in the process of testing activity mirror, and we're not reporting anything that individuals are doing in the bathroom, because that was something that we were very particular about. You know, it's a private place. You don't want to do something that's irresponsible. But in general, individuals have multiple caregivers helping them when they're showering, when they're using the bathroom, and it's quite common because some individuals need a lot of physical support, so the overturn is really high. So sometimes you have people who don't know that they're caregivers, but you don't know them, you don't have a personal, so a lot of them have a personal relationship, or they develop this relationship with their caregivers, but sometimes you have these people. It's also and some individuals don't like that, but I'm not really sure what the organizations are doing at the moment in addressing that, but they are aware of that issue. In terms of devices, like there is a trade-off between, you know, cameras, using computer vision and augmented for tracking, and you know, and you using cameras, but at the same time, like being able to provide that support. There is a trade-off there. So figuring out like what are some other means of accurately tracking people and being able to provide that individualized support in real time. I think that's a trade-off within this community, just given the number of implications around privacy and security. So I'd say it's a constant trade-off.
Julia, for sure.
Hi. Thanks for that was an amazing talk. Really, really interesting. You're doing so many things. That's very impressive. I just wanted to ask you if you've thought about, and I don't think you mentioned this particularly, but sorry if I'm wrong. Sorry, also my cat is joining us. Have you looked into different ways that you can provide voices that are like for avatars that can create rapport or that are empathetic? That would be really probably very useful and help people to feel comfortable using these devices.
Yeah, no, that's a great question. At the moment, we are only providing a limit because activity mirrors a prototype. We're providing a few voices to start off with, but that I see a lot of interesting ideas there around, you know, maybe having their favorite celebrity crush talk to them in the morning. This is really a big thing. A lot of people want Drake to, you know, encourage them to brush their teeth. Or help them do other activities. Or some people wanted themselves, which was really interesting. They wanted just themselves talking to them. So maybe have them in a way record their voices, or provide a way for users to have the people that they like talk to them. I think that's a really interesting idea. Like that's something I'll have to think about moving forward.
Yeah, I think that would be really interesting to try out, because these people seem like the ones you should be empathetic with more than anybody else. So anyhow, we can talk more about that later.
Yeah.
Thanks.
Great, and we have just one more question in the chat, which is from Sai Badi, who can't talk. What kind of impact does augmented reality bring to the general public?
Well, there's lots of impacts for general public in various areas, whether it's not just for everyday activities. So now I know a lot of gyms or other workout places that have these smart mirrors that you can work out with that use augmented reality. So that's one example, but there's a lot of implications around, let's say, in terms of public transportation, shopping, just other activity, navigation. So there's multiple areas where this could be useful, where you interact with technology and gives you a lot more information, whether that's visually or through audio or through other means. Maybe you have like a glove that can provide you haptic feedback, and if there's opportunity, and if it's available as a mainstream technology that everyone can use. So I see a lot of applications in different areas just to give you more information about the task that you are doing at that moment. I'm happy to discuss more if that, talk more about it. That doesn't answer your question.
Great. All right. I think that's it for questions. So thank you again.